Sup y'all, and welcome to Devolution of Power, Unit 5, Part 3. In 16th century Europe, almost everything known about science in the West had come from Africa, Asia, and the Islamic world. The European scientific revolution transformed the views of nature and society. No longer would the world be viewed as a mysterious and impossibly incomprehensible realm. This era championed the notion that everything in the natural world had a reasonable explanation, and there were rules that governed the universe. This idea was applied to physics, politics, economics, and has permeated into virtually every human endeavor. Without this revolutionary change in thought, our modern world would simply not exist as we know it. So, to begin, we'll ask, how did the scientific revolution affect human thought and lead to the modern world? Nicholas Copernicus, a Polish monk and scientist, proposed the heliocentric model with the sun at the center of the known universe. In doing so, he rejected centuries of European scientific dogma that believed in Ptolemy's geocentric model with the Earth at the center. However, his great discovery was not that the Earth revolved around the sun, since it wasn't actually all that original. While studying in Italy, Copernicus read the works of ancient Greek astronomers who had proposed the heliocentric theory 1800 years earlier. In 1543, on his deathbed, Copernicus consented to have his work published. This is because he was afraid of how the Catholic Church would react to challenging centuries of accepted thought. Most scientists and theologians at that time rejected his heliocentric model. Copernicus's great contribution was that studying and contemplating this idea would solve other problems. And thus began the scientific revolution, and the methodical pursuit to prove if Copernicus was actually right. This revolution would begin in only a handful of Western European countries, but its impact would change the world. Now, one of the most powerful phenomena in the universe is a supernova, like the one you see taking place right here. It happens when a star collapses and quite literally explodes from the inside out. And in 1572, a new star was observed above the constellation Cassiopeia by many people, including a Danish nobleman and astronomer named Tycho Brahe. Brahe used self-made instruments that were arguably the best in the world, and his measurements placed this new star, or nova stella as he called it, beyond the moon and known planets. And this went counter to the accepted belief that the stars and comets were around the Earth's atmosphere. Later, Brahe established an observatory in Denmark and hired several gifted mathematicians and astronomers. A key contributor to the Defense of Copernicus was a German mathematician and astronomer, Johann Kepler, who was for years an assistant to Tycho Brahe. Through extensive mathematical calculations, he concluded that the Copernican model was correct to a degree. However, each planet revolved around the sun in an elliptical orbit, not circular as Copernicus had predicted. What was emerging in Europe was a new methodology, different from the previous assertion that the universe was simply too complicated to understand. This new methodology was the scientific method. Enter an English lawyer, statesman, and scientist named Francis Bacon. He called for a new approach to scientific study, one that had already been undertaken by men such as Copernicus, Brahe, and Kepler. Bacon wrote that scholars should focus on observing reality rather than relying on analyzing the works of past thinkers. He is one of the pioneers of empiricism, the empirical approach that necessitates extensive observation and rigorous experimentation. In doing so, he laid the groundwork for the modern scientific method. Now, René Descartes, a French philosopher and scientist, further developed the modern scientific method, emphasizing human reasoning. Descartes agreed with Bacon that observation and experimentation was essential. This approach inspired the pursuit of mechanical laws that govern the material universe. Descartes stressed that everything must be proven except basic ideas that are true beyond a doubt. Perhaps his most famous quote encapsulated what he called the first truth, cogito ergo sum, which means, I think, therefore I am. Bear in mind, many of these men of this age were religious individuals and sought to discover the design of the universe as created by God. Descartes himself upheld that the physical laws he had uncovered revealed the mechanical perfection of the workings of the universe to be akin to a watchmaker, wherein the watchmaker is God. A true superstar of the era was Galileo Galilei, an Italian astronomer who combined his excellent creativity with experimentation and mathematics. And although he was not the first to assemble a telescope, he made several improvements and was the first to observe 4 moons revolving around Jupiter in 1610. He observed smaller objects revolving around a larger object by some unknown force. The discovery of celestial bodies orbiting something other than the Earth all but proved the heliocentric model. Most people then, as today, couldn't understand Kepler's mathematical proofs, but people could see with their own eyes. In 1616, the Church condemned the Copernican theory as heresy, and in 1633, Galileo was brought before the Inquisition. The Church forced him to renounce his findings. Galileo was spared, but he spent the rest of his days under house arrest. Nonetheless, he still researched, experimented, and made many new discoveries. Today, he is often referred to as the father of modern physics. To understand why Galileo was brought before the Inquisition, and not the others we mentioned before, we have to look to geography. Copernicus, Brahe, Kepler, Bacon, and Descartes published their works in Northern Europe, along the periphery or outer edge of the Vatican's influence from Rome. Distance decay prevented the Church from effectively containing these seemingly heretic works. By contrast, Galileo, an Italian, challenged the ideas supported by the Church. Since he resided around the core, or hearth, of the Church's sphere of influence, Galileo was forced into house arrest for the remainder of his life. So that makes Galileo a victim of geography. Although Galileo showed that planets revolved around the sun, he couldn't prove how it happened. Later, in the 17th century, Isaac Newton, an English physicist and mathematician, assimilated and consolidated Galileo's work, with others, synthesizing a new explanation as to how the universe operated. It is often recorded that Newton's epiphany occurred after witnessing an apple fall from a tree. If the force of gravity could reach to the top of a tree, couldn't it reach all the way to the moon and beyond? Newton used mathematics to discuss the measurable force of gravity, which explained why the planets moved as they did. To add to his resume, in order to do all the calculations he needed, Newton created calculus, as did Gottfried Wilhelm Leibniz, independently of Newton.
What's calculus?
So there you have it. Because of these scholarly giants, among others, the universe became more understandable and less mysterious, and the world became more intellectual and less superstitious.
That is correct.